Hi my friends, let's model the part number 51 cutter holder from my collection of 100 parts. The picture is here. You see is a tool holder with some features pretty interesting. Let's take a look at the drawing. You see there are some elements here to be respected. We start with revolving this contour, which is of revolution. You see here revolution and some extrusion on both views and other in this zone. We recognize a Morse cone here. We already modeled some of them in several previous tutorials. Let's start. The plane is XY. Let's draw the axis, which has a total length of 142, and to place it on the center point with two sections. The left one is 72. I'll show you in the drawing. 72. Having these two elements, we can create here a contour of the part, as I said, to be revolved. No more center line, conical, horizontal. Now is horizontal. I press Control and I have more freedom than without control. Perpendicular, horizontal, top, then a line and an arc. Continue and close contour. This is roughly the contour. Now we use dimensions. As I said, the total dimension is 142, and from here to the face, to this face, is 72. Let me move this a little, and also this, to have room here. You know that you can align. Okay. And this is 14.86, the end of a Morse cone, and 58.5 with this angle. This is the definition till here. Yes. Let's apply these dimensions. This is 7 This is one at 45 degrees chamfer, which is dimensioned here. So we are, and this is 18, like this one, I suppose. No, this comes from the end of this cone. Yes, this is cylinder with resulting diameter, and this is 18. I can prove this by applying this. Yes, this is not 18. Okay, we use this, and then 7.5, radius of 12, and the end is this one for the moment. Good. This is a diameter of 14.86. This angle is 1 degrees 25 minutes apostrophe and 50 seconds quote. Okay, now there is a length here of 58.5. As you can see, these are not horizontal, but I make them horizontal. Good. I apply coincidence of this line with this point. Good. This is 18, as I said. Oh no, they are aligned. Let me show you something. This is of the horizontal, this is of the vertical. And these are three. Why? The first is with this line. Yes? The other two are okay, this and this. But what about this? This means that this point is coincident with this line, and I don't want to be. I select that. Now I can move this line. This is 18, and this is resulting line from the left dimensioning. Yes, this is 20, and now the length of cylindrical part is 7. Look at it, this one, 2.5. There is no dimensioning here, but here is 2.5. Let's apply 2.5 to this, 2.5. Good. Now the left is okay. To the right, there is a diameter here, which maybe is this one, 24. A distance from this face, 7.5, and a radius starting with this diameter. Diameter of 24, 10 millimeters from this point to this, 10, a radius of 12, and the diameter here. This is the last dimension needed. What is that diameter? Radius of 16.5. This is not diameter but radius. 16.5. The revolution body is finished. F6, revolve, OK. We continue now with this extrusion, which has dimensions 10 millimeters from the axis, 10 from the left, and a radius of 10. The beloved XY plane F7 and the line from this point to the left, and then keep the left button of the mouse pressed and go out. As I said, this is 10 and the radius is also 10. The dimension of position of this line is also 10. To have no problems, we project this generator and we draw a line from the end of the generator to the left, then extend, trim, and the last line is the closure. This is fully constrained. We apply extrude now with cut, symmetrical all the way. OK. Now you see this is finished. OK. We go further. We see here that there is a cut and a symmetrical cut, and they are finished at 4 millimeters. We start by creating this plane, and the drawing, the sketch, will be created on this face. We start with the plane from here to the right, -4, and then F6. Let's create a sketch here, everything to be construction. I draw a circle, a full circle with this diameter, and I draw two lines in connection with not any internal element, like this circle, for instance. Vertical, vertical, or parallel with a vertical. OK. Now I apply equal to these two to be symmetrical, and the distance between them is 12, as I said. Good. Finish sketch. Extrude this and this. Cut 2 to this plane. OK. this is the elegant solution to our creation. I make this not visible, but not deleted. Be careful. Next is this cut with a slot radius 2 and a continuation of the thickness 3 of a cut, dimensions 5.5, 54. Let's create a sketch in the XY plane. I draw the slot 5.5 on horizontal, and then radius of 2, a rectangle, now regular rectangle, starting from this and going some there, and coincident this point with this arc. Now 3 is the dimension of this rectangle of the cut. Split this arc in 2 points and make construction this lines. Now I make aligned this line with this line, and on the same horizontal this point with the center of the slot. This is almost finished. The last is the dimension between this point and the end, which is 54. Fully constrained. Finish sketch, extrude, cut, symmetrical all the way. Okay, you see? Okay. Now I think to create this cut. Yes, as you can see here, or better here, is 20 distance from the middle up. 20. We use this plane for the sketch, F7, and then we place here a rectangle and dimension of 20. Finish sketch, extrude, cut the other direction all the way. Okay. Now there is another cut here. You see a hole and a continuation with 2 millimeters thickness, 43.5 and 2. Good. The same plane. The same plane to create this construction. F7, a circle of diameter 8, a rectangle, we already know the procedure, coincident this point with this, and dimension of 2. I'm sure that this is symmetrical with this. I split in 2 points because it is a circle, not an arc. Construction. I apply F7 to have this line to project. Yes. Again F7. Now I have the end to align collinear this line with this line, and to place it on the same horizontal with the center point. Now dimension. The dimension is 43 from the end. 43.5. Extrude the last contour, cut the other direction all the way. OK. Next is this cut with dimensions radius 11, 15, and placed at 16.5 from the bottom. Let's create it. A plane based on this face, up minus 16.5. This is the plane for the sketch. A circle with the radius of 11, F7, placed on the same horizontal with the center point and at a distance of 15 from the end. 15. Fully constrained. Extrude, cut all the way. OK. There is a hole here and another one here. Yes, metric 8 and 7. Let's start with metric 8. The face is this, concentricity with this, and metric ISO, everything is placed here, full depth. OK. This is the thread. And the other is placed here. A point F7 to have this point visible, and the position is 7.5. The distance is 31.5 from the end. Finish sketch. Hole, not threaded but simple. 7 all the way. OK. That's all. Only chamfers are to be placed, and we see here that one is at the end, two are here, and other two here. So chamfer one, also these two edges, and also right edges. Okay, that's all. Steel alloy and steel polished all over. This is the part. There was a small mistake. Instead of R16.5, I placed the value of 15.5, and this was at the beginning of modeling, so I want to change it. Double click. This is 16.5. Nothing else is with the problem, but only data. Now the data are 0.228 kilograms. That's all for today. Bye bye.